Hi everyone! This topic is all about radicals. Key questions. First, why are radicals important in mathematics? Second, what real-life problems lead in radical equations? And third, how do we solve real-life problems using radical equations? These questions can be answered later. Let's start. The word radicals comes from the Latin word radix, which means roots. It was first used by Leonardo da Pisa, Fibonacci, in 1220. The 16th century German symbol we use today probably is also derived from the letter R. We use radical symbol to denote the positive or principal square root of a positive numbers. The number inside the radical symbol is called radicand. Then, let's go to the properties of radicals. First, the product rule for radicals. Second, simplified form of a square root radical. Third, the product rule for higher order roots. And fourth, the quotient rule for radicals. Let's start first to the product rule for radicals. If a and b represent non-negative real numbers, then square root of a times square root of b equals square root of ab. The product of two square roots is the square root of the product of the radicands. The square root of a product is equal to the product of the square roots of its factors. Let's have the example. Letter A, square root of 3 times square root of 7 equals square root of 3 times 7, the product rule for radicals. And the answer is square root of 21, the simplified form. Letter B example, square root of 7x times square root of 5y equals square root of 7x times 5y, the product rule for radicals. And simplified form is square root of 35xy. Letter C example, square root of 15 times square root of 15 equals square root of 225, that's the product rule for radicals. And the answer is 15. Let's go to letter D example. Square root of 2 times square root of a plus b equals square root of 2 times the quantity of a plus b, that's the product rule for radicals. And it can be square root of 2a plus 2b, that's the simplified form. The second properties of radical is the simplified form of a square root radical that has three conditions. First condition, other than 1, the radicand has no perfect square factors. Second condition, no fractions appear in the radicand. Third condition, no radical appears in the denominator of a fraction. The product rule for radicals can be used to simplify radical expressions. Simplified square root are perfect squares under the radical sign. We can use the product rule to simplify a radicand that has not a perfect square but has a perfect square factor, such as square root of 12. Then, greatest square factor of 12 is 4. So we write 12 as 4 times 3. Thus, square root of 12 equals square root of 4 times 3. Then, square root of 4 times 3 can be write as square root of 4 times square root of 3. Then, square root of 4 times square root of 3 equals 2 square root of 3, because 3 has no perfect square factor other than 1. The expression 2 square root of 3 is the simplified form of square root of 12. Note, when simplifying square root expressions, always look for the greatest perfect square factor possible. To simplify more difficult radicals, it is important to know the integers that are perfect squares. Then, greatest square factor of 12 is 4. So we write 12 as 4 times 3. Thus, square root of 12 equals square root of 4 times 3. Then, square root of 4 times 3 can be rewrite as square root of 4 times square root of 3. Thus, square root of 4 times square root of 3 equals 2 square root of 3. Because 3 has no perfect square factor other than 1. The expression 2 square root of 3 is the simplified form of square root of 12. Note, when simplifying square root expressions, always look for the greatest perfect square factor possible. To simplify more difficult radicals, it is important to know the integers that are perfect squares. The following summarizes the procedure for simplifying square root radicals. Simplifying square root radicals when the radicand has a perfect square factor. First, write the radicand as a product of the greatest perfect square factor and another factor. Second, use the product rule for radicals to write the expression as a product of two radicals with a perfect square factor as one radicand. Third, evaluate the radical with a perfect square radicand. Let's have the example. Simplify square root of 75x cubed, where x is greater than 0. Use the product rule for radicals to simplify or to get the square root of 75x cubed. Square root of 75x cubed equals square root of 25x squared times 3x. That's the factor of 75x cubed. Then, square root of 25x squared times 3x equals or can be rewritten as square root of 25x squared times square root of 3x. That's the product rule for radicals. Then, square root of 25x squared times square root of 3x equals 5x square root of 3x. That's the simplified form of square root of 75x cubed. Let's have another example. Simplify square root of 45a cubed b squared, where a is greater than or equal to 0 and b is greater than or equal to 0. Square root of 45a cubed b squared is equal to square root of 9a squared b squared times 5a. That's the factor of the radicand. Then, square root of 9a squared b squared times 5a can be written as square root of 9a squared b squared times square root of 5a. That's the product rule for radicals. Then, square root of 9a squared b squared times square root of 5a equals 3ab square root of 5a. That's the simplified form of square root of 45a cubed b squared. The third properties of radicals is the product rule for higher order roots. For real numbers a and b and any integer n is greater than 1, nth root of a times nth root of b equals nth root of ab. If n is even, then a and b must be non-negative. Example. Simplify each radical. Letter A example. Cube root of 40. Cube root of 40 equals cube root of 8 times 5. The greatest perfect cube factor of 40 is 8. Then, cube root of 8 times 5 can be written as cube root of 8 times cube root of 5, the product rule for radicals. Then, cube root of 8 times cube root of 5 equals 2 cube root of 5 because cube root of 8 is equal to 2. Then the final answer is 2 cube root of 5. Letter B example. 2x cube root of 81 x cube y with an exponent of 4. 2x times cube root of 81 x cube y with exponent of 4 equals 2x cube root of 27 x cube y cube times 3y. 2x cube root of 27 x cube y cube and 3y can be written as 2x cube root of 27 x cube y cube times cube root of 3y. Then 2x cube root of 27 x cube y cube times cube root of 3y equals 2x times 3xy times cube root of 3y because 27x cube y cube equals 3xy. Then the final answer is 6x squared y cube root of 3y. Let's go to the fourth properties of radicals. The quotient rule for radicals. If A and B represent non-negative real numbers where B is not equal to 0, then square root of A over B can be written as square root of A divided by square root of B. The square root of the quotient is equal to the quotient of the square roots of the numerator and denominator. Let's have the example. Simplify each quotient. Letter A example. Square root of 28 x cubed divided by 7x can be written as the quotient rule for radical square root of 28 x cubed divided by 7x. Then, square root of 28 x cubed divided by 7x equals square root of 4x squared. Then, square root of 4x squared can be simplified as 2x. Then, letter B example. Square root of 48x with exponent of 9 divided by square root of 6x cubed can be also be written as the quotient rule for radicals square root of 48x with exponent of 9 divided by 6x cubed. Then, square root of 48x with exponent of 9 divided by 6x cubed equals square root of 8x with exponent of 6. Then, square root of 8x with exponent of 6 can be simplified as square root of 4x with exponent of 6 times 2. Then, the final answer is 2x cubed square root of 2. This is the other rule for the quotient rule for radicals. For real numbers a and b, with b is not equal to 0 and any integer n is greater than 1, then nth root of a divided by nth root of b equals nth root of a over b. If n is an even integer, a must be non-negative and b must be positive. Example. Simplify each radical. Letter A. Example. Cube root of a squared divided by 27 can be written as the quotient rule for radicals. Cube root of a squared divided by cube root of 27. Then, evaluate the radicals. Cube root of a squared divided by 3 is the final answer. Let's have letter B example. Cube root of 40 divided by 125 can be written as the quotient rule for radicals. Cube root of 40 divided by cube root of 125. Then, factor out the perfect cube radicand in the radicals. The answer is cube root of 8 times cube root of 5 divided by cube root of 125. Then, the simplified form is 2 cube root of 5 divided by 5. That is the final answer. Then, the final answer is 2 cube root of 5 over 5. Thank you for watching! Then, the final answer is 2 cube root of 5 over 5. Thank you for watching!